Hey Globey, I'm gonna catch a meteorite. That's right. Any minute now, a meteorite is gonna fall from the sky, and I'm gonna be right here to catch it. That's right, any minute now. Okay, we actually might be here for a while, because you see, even though meteorites fall to Earth every day, we might have to wait around for over 1,000 years or so to actually catch one in this spot. Since this show's roughly about 5 minutes long, I better get right to the point. Today we're going to learn about how NASA's been studying meteorites and comet dust to learn more about our world. Dr. Mike Zielinski is a cosmic mineralogist at NASA's Johnson Space Center in Houston, Texas. He studies rocks from outer space. These space rocks are called meteorites and are basically samples from other worlds. These samples contain the materials, like carbon, that make up our planet and other planets in our solar system. Scientists call these materials the building blocks of the universe.
All the compounds that make up you and me and all the world around us are in this rock. I mean, it isn't alive, it was never living, but all the building blocks of all those things are in here. So we think that the Earth and the moon and the sun form from rocks just like this. And so by getting these, cutting them, and bringing in labs like this one right here, and analyzing them with things like this machine right here, we can find out a lot about where all the planets came from, how they formed, and maybe a little bit about where we came from as well.
So how do mineralogists like Dr. Zielinski find these meteorites? Well, some of these meteorites have already fallen to Earth. So where are the best places to find them? Places like the desert are great because they don't contain rivers or oceans that could hide the meteorites or wash them away. Also, most people don't want to live in the desert, so sometimes these meteorites go undiscovered in the deserts for thousands of years. But the best place on Earth to find meteorites is at the South Pole in Antarctica. The area is cold and dry, and until recently, humans rarely went to the Antarctic. So there are many meteorites waiting to be found there. In fact, some of these meteorites have been lying there on the ice for millions of years. Dr. Zielinski is part of an important mission at NASA to study other kinds of rocks, tiny little particles that can be found in comets. Let's ask Dr. Zielinski what a comet is.
Comets are icy objects, and you see this is a chunk of a very, very cold ice, special ice called dry ice. It's super cold, like you have in space, and there's rock attached to it here. And this sort of thing, this is where most of the rocks from space come from. They come from real icy, rocky objects that are orbiting the sun, and they're mostly composed of ice here, which is frozen gases and frozen water. And these comets are always flying around the sun, and they're giving off particles.
So how do scientists like Dr. Zielinski study comets? I mean, how do you actually get a sample of a comet? Stardust is the name of a mission created by scientists all over the United States in cooperation with NASA. The purpose of this mission? To investigate a comet called Wild 2. Interesting name, isn't it? During the Stardust mission, a spacecraft was launched from Earth on February 7, 1999. It took 7 years just to complete the mission. The Stardust spacecraft traveled nearly 4.8 billion kilometers to reach the comet. We could make 6,000 trips to the moon and back before we traveled that far. Once the spacecraft reached the comet, it opened up like a giant collector dish to capture samples of the comet's dust.
Well, it's more like a catcher's mitt. The clamshell opened up, the catcher's mitt came out, and as the comet dust grains smacked into it, it's like catching baseballs, thousands of baseballs, but very tiny microscopic baseballs. These grains are smaller than the width of a human hair.
This comet dust was collected in a substance called aerogel. Aerogel is so light that when you hold it in your hand, you can't even feel its weight. Aerogel begins as a gel, much like the gelatin you eat. The material then goes through a special process where the liquid is taken out without collapsing the gel. The result is an amazingly strong, lightweight material. 7 years after the Stardust spacecraft was launched, it returned to Earth on January 15, 2006. Scientists then had access to all of this comet dust that was stored in the aerogel.
Basically, everyone here is very calm. So you know how some of your friends are like constantly like this, they just can't settle down right. And some people are really calm, you know, they're really all like this all the time, kind of laid back. That's how we are. And people like that can very carefully take little pins and just pick up little microscopic things. You do it under a microscope and move from place to place, pick them up, set them down on places like this, this microscope like this, to study. And so it takes a special kind of person who's very calm and They're very hardworking, but a lot of people are like that. So a lot of kids out there watching this, I'm sure this is the job for you, right? Not everyone, but for some people who are really curious about what's out there in space and where the Earth came from, and really have the drive to learn about it.
But the mission was worth the time and effort. Scientists like Dr. Zelinsky discovered not only the dust they expected to find in the aerogel, but small crystals as well. And by studying these small crystals, scientists have already changed some of their ideas on how and where comets are formed. So, Globey, today we learned that meteorites and comet dust contain particles that are the building blocks of the planets in our universe. And when scientists get the chance to study these particles, they can find out more about our own world. Maybe one day you'll get to find a meteorite. And remember, if you hold one in your hand, you're holding something that may be millions and millions of years old. Maybe even older than Earth itself. That's pretty cool, isn't it? All right, let's go. Come to Papa.